First of all, I would like to welcome all the delegates to this international web conference on science, engineering and technology 2020, which is going to held on May 15 and 16. The title of my presentation is Phycoremediation, an effective technology for the removal of total dissolved solids from water and wastewater using biological material. As we all know that water is one of the most abundant and wonderful natural resources which is highly essential for the survival of all the living organisms. But today the clean water has become a precious commodity and its quality is threatened by various factors. The few major factors which I would like to highlight here: the rapid population growth, industrialization, urbanization, increasing living standards and wide spheres of the human activities. All this resulted in the degradation of the water quality. All these factors are responsible for the deterioration of the water quality. It has been observed that in recent years, increase in freshwater contamination leads to a deterioration of the qualitative water bodies, both surface as well as the groundwater. According to one of the report published by the Central Pollution Control Board, New Delhi, because of the industrial and the municipal waste discharge, the number of rivers are polluted in India has almost doubled in last 5 years. Even the states which are adjacent to the coastal lines, they have also showed the contamination of groundwater with high salinity. Excessive exploitation, then lack of the rainfall, more water demands are the few factors responsible for the decrease in the groundwater levels, and therefore there is a great need to adopt the new technological invention so as to treat the water and the wastewater for its use to reduce the stress on the natural resources. Total dissolved solid is the mineral ingredient always you will find in surface water, groundwater as well as the wastewater coming from few industries. These are the found in dissolved as well as soluble form in water. The most common ones are carbonates, chlorides, sulfate, phosphates, nitrates of calcium, magnesium, sodium and iron, etc. High TDS causes the water to look colored, highly turbid, then unpleasant taste if it has obnoxious dissolved constituents. The maximum part of our freshwater system or the surface water is highly polluted because of the total dissolved solids nowadays. Similarly, in coastal states also, it has been observed that the groundwater system is also facing the numerous threat from the contamination of the high TDS. Therefore, groundwater is not useful for drinking in most of the coastal states of our country. In addition, nowadays, the research has been initiated for the application of the various algae species under the phycoremediation to treat the water and the wastewater and the effluent from the industries generated in a very eco-friendly manner. Phycoremediation is one of the application of the microalgae for the removal of the biotransformation or the bioaccumulation of the pollutants. Algae are prominently found in fresh and marine aquatic environment with a wide range of the diversity and habitats. The main aim of the study, the main and objective of my study is to find the possibility of the microalgae for removing the dissolved solids. The objective is to use the better option by using the algae for the removal of total dissolved solids under the different concentration level and the conditions. Therefore, first we have carried out the sampling of the 4 highly polluted lakes of our Nagpur city. Those are namely the Ambazari, Gandhi Sagar, Futala, Sakkadara, for the collection of the algae. These are some of the few photographs from where we have carried out the sampling of all those algae. Then what are the material and method required? Then here under the method, first we have inoculated that sample, then we have identified the algae with the help of the literature, then we have added the pure culture, then we have set up entire experimental setup. Then it has been found that Chlorella and Sysmatismus, these are the 2 main algae which we found, and we have taken this for the experimentalization purpose. Then we have prepared a synthetic water with different concentration of the total dissolved solids by adding sodium chloride in distilled water. Then we have calculated the total dissolved solids. Then we have also added the nutrients, and then we have analyzed the total dissolved solid as per the prescribed method. Then experimental work has been carried out. Nutrients were added. 1 ml of pure culture of algae was taken in each flask. The flasks were hand shaken. The setup was kept on the tissue culture rack, and white fluorescent artificial light for 10 hours per day we have provided. The flasks were kept for 20 days, and the pH and the TDS were examined after every 5 days duration. The pH was measured with the help of pH meter and standardization of the instrument, and the TDS was measured by the gravimetric method. The experiment was operated in the laboratory scale. This is one of the photographs which I would like to show you, which I would like to mention here for the experimental setup. Then we have carried out the pH values for the Chlorella. Then we have also found the removal of TDS with the help of the same algal species. Then from the graph, it has been clear that the Chlorella is helpful in removing the total dissolved solids. Then we have also gone for the second algae, that is Sysmatismus. Here we have carried out the pH experiment initial and the after 5 days. Then it has been also observed that the same algal species is also removed for the TDS. From graph also it has been clearly mentioned that it has been observed that this species is also removing the total dissolved solids. During the study, the initial TDS values observed of synthetic water were 500 to 3500 before the phycoremediation. After phycoremediation using the Chlorella species, it has been found the maximum reduction. From the result, it is observed that the removal of the TDS with Sysmatismus was also observed with a great reduction. This clearly indicates that the considerable and the progressive removal of the TDS from the synthetic water are likely due to the uptake of the salts by both the algae. After the experimentation, it has been observed that suitable strains of the green algae, which is less affected by the adverse condition of the saline water, but is helping in removing the dissolved salts to a higher extent. Finally, I would like to conclude that the process of the performance of the phycoremediation with the 2 algae is determined in synthetic water with high TDS. Therefore, the result further suggested that the Chlorella have high removal rate of TDS concentration as compared to the second algae which we have taken in experimentation, that is Sysmatismus. Therefore, both the algae could be used to promote a low-cost green technology for water and the wastewater treatment for the removal of total dissolved solids in developing countries. India, as we all know that it is a tropical country with abundant of sunshine, is suitable for the implementation of the phycoremediation as one of the new technology. The present phycoremediation technique is an emerging tool for the removal of total dissolved solid from water as well as the wastewater. I am very much thankful to both of my friends, Dr. Revatkar sir, who has given me this wonderful opportunity to share my project work in front of this August gathering. Thank you, sir. Thank you very much, sir. I am again thankful to the organizers for organizing such a beautiful conference in a short period of the time.